intensity distribution curve and energy conservation principle in intensity distribution, I mean interference pattern. So first I am coming to conditions of maxima and minima. First at maxima, at maxima cos delta is equal to +1. That means cos delta should be equal to cos 2n into pi. So
Sir,
delta
today
is
in the
equal
class
to
we
this
have
is
one birthday
plus
boy.
minus. Yes. हेलो, कोई कुछ बोल रहा है क्या? व्हाइट बोर्ड दिख रहा है या नहीं दिख रहा है?
सर दिख रहा है सर, बस थोड़ा सा ब्लर दिख रहा है।
नहीं, ब्लर नहीं है।
वो फोकस हो जाने से हो जाएगा सर।
हाँ?
सर फोकस हो जाने से हो जाएगा।
फोकस?
तो शायद मेरा ही नेटवर्क थोड़ा लो है सर, इसलिए मेरे को ब्लर दिख रहा है।
हाँ, क्या बोले जोर से?
सर मेरा नेटवर्क शायद स्लो है क्योंकि मुझे ब्लर दिख रहा है थोड़ा।
नहीं सर, हमें भी दिख रहा है सर, थोड़ा थोड़ा सर, थोड़ा दिख रहा है ब्लर।
नहीं, ये तो क्लियर दिख रहा है
सर, लेकिन है सर थोड़ा ब्लर।
ये सर हमारे लिए सर थोड़ा ब्लर दिख रहा है सर।
ओके ओके, ठीक है। At maxima, cos delta should be equal to +1. This happens when cos plus minus 2n pi. अभी ठीक है तो?
यस सर, ठीक है।
ये सर अभी ठीक है सर।
This means delta should be equal to plus minus 2n pi, where n should be equal to 0, 1, 2, etc. कहाँ तक इक्वेशन नंबर गया था? लास्ट क्लास में इक्वेशन नंबर कहाँ तक गया था?
7
अरे
2
लास्ट, हाँ?
7 2।
7।
यस सर।
तो इसको 8 आई करो। इन टर्म्स ऑफ पाथ डिफरेंस अगर आप लिखना चाहते हो तो डेल्टा इज इक्वल टू 2 पाई बाय लैम्डा इनटू जेड. This gives that 2 pi by lambda into z should be equal to plus minus 2n into pi. Pi cancels out. So z should be equal to plus minus 2n into lambda by 2. These are the conditions for maxima. And we have seen that at maxima the intensity is given by I1 plus I2 plus 2 root over I1 I2, which is equal to root over I1 minus plus root over I2 whole square. That is what we have already seen. If you go to minima, cos delta should be equal to -1. That means this should be equal to cos plus minus 2n plus 1 into pi, where n should be equal to 0, 1, 2, etc. So this means that delta should be equal to plus minus 2n plus 1 into pi. Condition for minima. Now, in terms of path difference, if you want to know, delta is equal to 2 pi by lambda into z. plus minus 2n plus 1 into 5. So z should be equal to plus minus 2n plus 1 into lambda by 2. Given integral multiple of 5 is maximum or integral multiple of 5 is minima. These are the conditions. And maxima, at maxima, what will be the resultant intensity? At minima, what will be the resultant intensity? That we have already obtained. Is it clear or you have any doubt?
Clear, sir.
क्लियर सर.
नेक्स्ट हम लोग आएंगे इंटरफेरेंस पैटर्न में इंटेंसिटी डिस्ट्रीब्यूशन कैसे होता है. इंटेंसिटी डिस्ट्रीब्यूशन मतलब ये सोर्स S1 है, ये सोर्स S2 है, इसका एम्पलीट्यूड A1, इसका एम्पलीट्यूड A2, दोनों का एंगुलर फ्रीक्वेंसी सेम. इस रीजन में हर एक पॉइंट में S1 से जाने वाला वेव S2 से जाने वाला वेव सुपरपोज कर रहे हैं, लेकिन अलग अलग पॉइंट के लिए डेल्टा का वैल्यू अलग अलग है और रिजल्टेंट इंटेंसिटी का एक्सप्रेशन ये है I1 plus I2 plus 2 root over I1 root over I2 cos delta. So I is a function of delta. Since delta is different at different points, hence obviously intensity will be different. Then if I go from a point A to another point B along a particular direction, whatever intensity I find here, here it will be a different intensity, here it will be a different intensity. So I want to see how the intensity changes with position. That is what we say intensity distribution. Two cases may arise. Case one, when amplitudes are different or two waves is different. In this case, I maximum root over I1, root over I2 all square या k into A1 plus A2 का all square and I minimum root over I1 minus root over I2 all square which is equal to k into A1 minus A2 का whole square. So you can mark because A1 is not equal to A2. So obviously the minimum intensity is not equal to 0. That means the intensity at minima is not equal to 0. Moreover, because of this expression, it is very clear that intensity, whether cos delta is positive or cos delta is negative, intensity always will be positive. So if I plot the graph, so this side you take intensity, this side you take delta or Z, whatever it may be. You can take first delta. Suppose this is equal to 0 and this is equal to say pi, 2 pi, 3 pi, 4 pi, minus pi, minus 2 pi, minus 3 pi, minus 4 pi. Assume now I maximum is equal to this one. So suppose this is I maximum. You know I maximum as a value as well as I minimum is also not equal to 0. So this is I minimum. Then the intensity lies in between this minimum to maximum. Now this is the line at pi. Draw a dotted line so that it will be very clear. At 0, the intensity is maximum. At pi, the intensity is minimum. So it reduces like this. At 2 pi, the intensity is maximum. It increases. At 3 pi, it goes minimum, decreases, then again increases, and so on. So the solid curve gives the variation how the energy changes. This is when amplitudes are not equal. But if you came down to case 2, if you want to plot this graph in terms of J, path difference, then this corresponds to 0, this corresponds to lambda by 2, 2 lambda by 2, 3 lambda by 2, 4 lambda by 2, minus lambda by 2, minus 2 lambda by 2, minus 3 lambda by 2, minus 4 lambda by 2. So this is how we can correspond it. If you want to plot in terms of path difference, intensity versus path difference. What you can mark your own interesting thing, whatever variation in intensity you see in between 0 to 2 pi, the same intensity variation you see in between 2 pi to 4 pi. Mark that the intensity variation is periodic with delta, and the period after which intensity repeats is 2 pi. So 2 pi के बाद वही इंटेंसिटी फिर रिपीट कर रहा है. ये हुआ अगर एम्पलीट्यूड सेम नहीं हुआ, अलग अलग है. Now we are coming to the case when the amplitudes are not equal, in fact not equally equal. So this is the case 2 when amplitudes are equal. So when amplitudes of two waves are equal, A1 is equal to A2. In this case, I maximum root over I1 plus root over I2 whole square. So this implies that I1 plus I2, I1 is equal to I2. So this is equal to I say, but anything else you can take. Then this is equal to K into A1 plus A2 whole square, because A1 is equal to A2 is equal to A. So this comes as 4A square. and I minimum root over I1 minus root over I2 whole square k into A1 minus A2 whole square, which is equal to 0. So if the amplitudes are equal, at the minima the intensity is 0, and at maxima the intensity is 4 times intensity of one wave maxima पे। तो इसी को देखते हुए हम लोग ग्राफ प्लॉट करेंगे आई 0 पाई 2 पाई 3 पाई 4 पाई minus 2 pi minus 3 pi minus 4 pi. Suppose this is I maxima, I minima is 0. Draw the vertical dotted lines. This is the maxima. And if you plot the intensity at 0, it is maximum, reduces, becomes 0 at pi. Only difference is that your minima will have a 0 value, 0 intensity. Just mark it is a cross graph. So this is the case when the amplitudes are equal. Is it clear? Any doubt? If you have any doubt, please respond.
No, sir.
राइट साइड को मिटा रहे हैं।
सर 1 मिनट सर।
लिखो
हो गया सर।
राइट साइड हो गया।
हो गया सर, पूरा हो गया।
Now we shall discuss interference and energy conservation. As we have seen, in region of constructive interference, cos delta is positive. So resultant intensity, which is equal to I1 plus I2 plus 2 root over I1 root over I2 cos delta is greater than I1 plus I2. It appears as if energy is created at point of constructive interference. क्योंकि कंस्ट्रक्टिव इंटरफेरेंस पॉइंट में हम लोग देख रहे हैं रिजल्टेंट इंटेंसिटी दोनों वेव से आने वाला इंटेंसिटी का सम से भी ज्यादा है, तो ये लगता है कि जैसे पॉइंट पर कंस्ट्रक्टिव इंटरफेरेंस पॉइंट में जैसे एनर्जी क्रिएट हुआ. सिमिलरली at points of destructive interference, cos delta is negative, then I, which is I1 plus I2, 2 root over I1 root over I2 cos delta appears to be less than I1 plus I2. It appears as if at points of destructive interference, the energy is destroyed. It appears so. That is, it appears as if energy conservation principle is violated at regions of, at points of constructive or destructive interference. But practically, this is not so. But practically, this is not so. ऐसा होता नहीं है. Energy from points of destructive interference transfers to points of constructive interference. Thus, making a non-uniform intensity distribution pattern in region of superposition. We can check that the average energy or average intensity in the region of superposition is equal to sum of intensities of two superposing waves. कैसे? I average, I know I is equal to a function of डेल्टा. ये हम जानते हैं, अलग अलग पॉइंट में डेल्टा अलग अलग है. राइट साइड को मिटाएंगे, राइट साइड को मिटा देंगे क्या? हेलो, अरे बोलो, राइट साइड को मिटा देंगे या और थोड़ा वेट करेंगे? आप जो बोलोगे उसके.
सर और थोड़ा वेट कीजिए, थोड़ा सा,
हाँ,
थोड़ा 2 मिनट सर.
ठीक है, 2 मिनट रुकते हैं. हो गया, मिटा दो राइट साइड को.
यस सर.
हेलो, हाँ, ये बुझले मु क्लास रे छी ओ अच्छा मु क्लास रे छी क्लास पर कॉल कर छी ना तो since the intensity varies with delta periodically with period 2 pi, so I average can be calculated by integrating from 0 to 2 pi I d delta divided by 0 to 2 pi d delta. Now this gives me 0 to 2 pi I1 d delta plus 0 to 2 pi I2 d delta plus integration 0 to 2 pi 2 root over I1 root over I2 cos delta into d delta divided by 2 pi. If you carry out this integration, the result will be 2 pi. So this gives me I average is equal to I1 into 2 pi plus I2 into 2 pi plus 2 root over I1 root over I2 0 to 2 pi cos delta d delta divided by 2 pi. But integration cos delta d delta 0 to 2 pi is equal to 0. So this gives me I average is equal to I1 plus I2. So the average intensity is equal to sum of the intensities of the two waves. This is the proof that energy conservation principle is not violated. Many times this proof mathematically is asked to the students. Finally, I want to note down the conditions of interference here. Conditions of good quality interference pattern. Practically, that is pattern लेना. One, for sustained interference pattern, or you can write like this: a sustained interference pattern is one in which the intensity at any point does not change with time. अगर किसी पॉइंट का इंटेंसिटी टाइम के साथ चेंज नहीं हुआ तो हम लोग उस इंटरफेरेंस पैटर्न को सस्टेन्ड इंटरफेरेंस पैटर्न बोलते हैं. Since I is equal to I1 plus I2 plus 2 root over I1 root over I2 cos delta, so for sustained interference pattern, delta should not change with टाइम. अगर डेल्टा टाइम के साथ चेंज होगा तो आई टाइम के साथ चेंज हो जाएगा तो इंटरफेरेंस पैटर्न सस्टेन नहीं होगा. Hence, two sources must be coherent. क्योंकि जिसमें फेज डिफरेंस टाइम के ऊपर डिपेंड नहीं करता है उसको बोलते हैं कोहेरेंट सोर्सेस। इसीलिए सस्टेन इंटरफेरेंस पैटर्न के लिए हम लोगों को चाहिए दी सोर्सेस मस्ट बी कोहेरेंट। टू, a good in contrast interference pattern is one in which there is large difference in intensity at maxima and minima। अगर मैक्सिमा का इंटेंसिटी और मिनिमा का इंटेंसिटी बराबर हुआ या करीब करीब हुआ तो मैक्सिमा को मिनिमा से अलग करके डिस्टिंग्विश नहीं किया जा सकता। Then we say the interference pattern is a poor contrast. This happens when amplitudes of two waves are equal or nearly equal. So second condition is amplitude should be equal or nearly equal. 3, for practical applications of interference pattern, we need that the fringe width should be more। fringe width आप जानते हो डिस्टेंस बिटवीन टू कंसेक्यूटिव मैक्सिमा, यंग्स डबल स्लिट एक्सपेरिमेंट आप पढ़े थे। This happens when the two sources S1 and S2 are placed very close to each other. Then the consecutive maxima and minima are first separated and the consecutive maxima and minima are first separated and we say interference pattern has good resolution। 4, for two superposing waves must superpose in same state of polarization। So these are 4 important conditions that are required for a good quality interference pattern। Any doubt if you have, you can ask। Any doubt? Any doubt, anyone? Would you understand all these things?
No, sir.
Okay. So these all are many things on which questions may come. Today we will stop here. In the next class, we shall discuss about the different practical processes we have to follow to obtain coherent sources, because coherent sources are required for interference pattern. How do we get coherent sources? Basing upon that, interference pattern is categorized into two groups. Interference by division of amplitude, interference by division of wavefront. The Newton's ring experiment that you did also is a very important question that comes under the category of interference by division of amplitude. So in coming classes, 3 classes maybe, we will discuss all these things and finish interference. Then we will move forward to diffraction. My plan is to finish diffraction maximum to maximum by May 10 or May 12, so that we can finish the syllabus in time. So I need your cooperation. Bye.
Thank you, sir. Bye bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, sir. अभी क्या है बीच में लेना?